This is my choosing topic about of internationally published paper that present the RGB value to the image. My choosing topic was all about a theory based on conversion of RGB image to gray image. Authors Tarun Kumar, Karan Verma, journal name International Journal of Computer Applications 7. Abstract. The use of color in image processing is motivated by two principal factors. First, color is a powerful description that often simplifies object identification and extraction from a scene. Second, humans can discern thousands of color shades and intensities compared to about only 2,000 shades of gray. In RGB model, each color appears in its primary spectral components of red, green, and blue. This model is based on Cartesian coordinate system. Images represented in RGB color model consist of three component images, one for each primary. When fed into an RGB monitor, these three images combine on the phosphor screen to produce a composite color image. The number of bits used to represent each pixel in RGB space is called the pixel depth. Consider an RGB image in which each of the red, green, and blue images is an 8-bit image. Under this condition, each RGB color pixel is said to have a depth of 24 bits. MATLAB 0.2007b was used for the implementation of all results. Keyword: RGB image, gray image, MATLAB pixel. First, image types. There are three types of image, which is described below. First, binary image. Logical array containing only 0 and 1 is interpreted as black and white respectively. Second, grayscale image. It is also known as intensity grayscale or gray level image. Array of class Unit 8, Unit 16, and 610 single or double whose pixel values specify intensity values. For single or double arrays, values range from 0 to 1. For Unit 8, values range from 0 to 255. For Unit 16, values range from 0 to 6,535,000. For Int 6, values range from negative 3,002,768 to 3,002,767. And third, the true color image. It is also known as an RGB image. A true color image is an image in which each pixel is specified by three values, one each for the red, blue, and green components of the pixel's color. M by N by 3 array of class Unit 8, Unit 16, single or double whose pixel values specify intensity values. For single or double arrays, values range from 0 to 1. For Unit 8, values range from 0 to 200 to 55. For unit 16, values range from 0 to 6,535. This is an image of grayscale images. Figure 1, grayscale. Figure 1b, through color. Figure 1c, binary. Grayscale images. Image formation using sensor and other image acquisition equipment denote the brightness or intensity I of the light of an image as two-dimensional continuous function f x and y, where x and y denotes the spatial coordinates when only the brightness of light is considered. Sometimes three-dimensional spatial coordinates are used. Images involving only sensitivity are called grayscale image. Resolution. Similar to one-dimensional time signal, sampling for images is done in the spatial domain, and quantization is done for the brightness values. In the sampling process, the domain of images is divided into m rows and m columns. The region of interaction of a row and a column is known as pixel. The value assigned to each pixel is the average brightness of the regions. The position of each pixel is described by a pair of coordinates xl and xj. The resolution of a digital signal is the number of pixels the number of pixels presented in the number of columns, number of rows. For example, an image with a resolution of 600 times 480 means that it displays 640 pixels on each of the 480 rows. Some other common resolution used is 8000 times 600 and 1024 times 728, among other. Resolution is one of the most commonly used ways to describe the image quantity of digital camera or other optical equipment. Figure 3 shows the image of a 24-bit color RGB, 3 channels component and corresponding pixel information image. Figure 3A, RGB images. Figure 3B, a pixel images of A. Figure 3C, red channel. Figure 3D, pixel image of figure 3C. The gray labels. Gray labels represent the interval number of quantization in grayscale image processing. At present, the most commonly used storage method is 8-bit storage. There are 256 gray labels in an 8-bit grayscale image, and the intensity of each pixel can have from 0 to 255, with 0 being black and 255 being white. Another commonly used storage method is 1-bit storage. There are 2 gray labels with 0 being black and 1 being white, a binary image, which is frequently used in medical images, is being referred to as binary image. As binary images are easy to operate, other storage format images are often converted into binary images when they are used to enhancement or age detection. Figure 1 and Figure 1a and Figure 1c shows a typical grayscale image and a binary image respectively. This picture shown as the gray labels. Figure 2a gray image, Figure 2b pixel image of A. Number 3, RGB color model. In RGB color model, each color appears in its primary spectral components of red, green, and blue. The color of a pixel is made up of three components: red, green, and blue. RGB described by three corresponding intensities. Color componenta are also known as color channel or color planes components. In the RGB color model, a color image can be represented by the intensity function IRGB equals R if R and if G and if B, where if R X and Y is the intensity of the pixel, X and Y in the red channel, if G X and Y is the intensity of pixel, X and Y in the green channel, and FB X and Y is the intensity of pixel X and Y in the blue channel. The intensity of each color channel is usually stored using 8 bits, which indicates that the quantization level is 256. That is, a pixel in a color image requires a total storage of 24 bits. A 24-bit memory can express as 224 equals 256, 256 and 250 equals 1,16,7,216. This picture represents the RGB color model. Figure 3E green channel, Figure 3F pixel image of Figure 3E, Figure 3G blue channel. Table 1 result comparisons with Brown method. Pixel number 1 by MATLAB, 184 by method, by R method, percentage error, Brown method, percent error of R method. This is the table result of comparison with Brahman method. For conclusion, in section 3, RGB model is shown and also show how we split RGB image into RG and B component image. Using MATLAB, we convert color image into gray image. Then the intensity of the pixel in gray image changes according to the proposed transformation equation, which are explained above. Another way for proof is MATLAB snapshot. In figure 3b, showed the intensity value of RG and B channel individually using RG and B value and proposed transformation equation. In section 3, calculate the intensity of gray label image, then matching with the figure 2b. In this way,